Alright, this is my bit and brace, and just by hand I can go ahead and roll a nice little edge on that. Take the sharp edge that's hanging off. Alright, now we'll roll it over here, and of course this is at an angle here, but we can just come into it like this. There we go. Alright, with the bird there. Alright, we're getting ready to make the second part of our project. We finished the pin and we have it sitting down on the floor, and now we're going to make the two sleeves that actually slip into the two sets of jaws intertwined with each other so that the eyes all line up. These sleeves slide in from the inside out, and then the main boom on the excavator slips down in through there against the two flat faces here, and the pin goes on through and holds the whole system together. Now these tubes here, we ordered up a piece of material. We got it cut in half already, so we have two 1-foot pieces here. We're getting ready to slap these into the lathe now and start it turning. Then this flat plate we actually have in sitting next to our plasma cam. Excuse me. And we're gonna rough those out in on the plasma cam. Then we're gonna bring them in here. We'll forge on, and we're gonna machine them, and then they are gonna get welded together. Now I'm gonna bring you in here close, and you can see right in here where they've torched to get this thing out. The pin was bent up pretty good because somebody didn't put the right abuse or a couple other reasons. I don't know. But we're going ahead and we're putting together what we feel should be in this piece of equipment. And we've done a file test, and I can groove that, and I can also groove the weld. I can groove the sleeve and everything else. So this is the original part here, and this is not a hardened piece. But I made the tube out of 4140, heat treated and tempered. Or excuse me, quenched and tempered. And I'm going to make this flat plate out of a piece of AR, abrasive resistant material. And then I'm going to go ahead and weld that with stick rod. And then after we do that, we're going to go ahead and we're going to heat that welded area up with the torch till we get up to about 1650 or so in that ballpark area. And then we're going to let it air cool so that it'll stress relieve the AR plate and this weld joint won't be so weak. There's no load on here except for keeping the sleeves from spinning, but this is crushing concrete, and it's going to have a lot of vibrations and things like that, and that's why we're going to go through the motions that we're going to go through so that we're giving them the best wearing face. And the pivot material is going to be as strong as we can get it. So let me bring you in close and give you a look, and you can see that, through the remnants of where they've cut here on both sides, I can tell that this was just a weld bead around the face of here on the original construction here. Now you can see the open gap that's in between the layers, and there was a V prep in here. There's no weld prep on the back side here because that's a square shoulder, and you can see remnants down in here on each of these sides, right in that area there, and also over in this area right here. And you can see that there actually was a press fit or something like that, and then a single weld bead around there, and then refaced off afterwards. And here again you can see that I'm able to put file grooves in anywhere on this this project here. So we're not working with extremely hard materials, but we're going to put in as hard as we can materials without actually going through a heat treat on it. Okay, we're going to be using the forge on our bell center for our first setup here, and we want to skim the entire OD and skim the face in as far as we can reach to the bell center. We know we're going to have material coming out of the bore, but we can give it a clean face cut, which will be the finished cut, on both ends of our part in this setup here. Now what I'm going to do is we're going to grab the inside of the tube with the jaws, and I'm going to take, this could be steel key stock, it could be whatever you want to space back here. I kind of had some short pieces and I cut 2 more to match the 2 I had of 3/8 key stock here. That leaves about a 1/4 inch of jaw left here. Now I'm going to take a rubber band, and this is a little different than, oh. Alright, you've seen me stick things into jaws and stuff like that with monkey shit, but here I'm going to go ahead and use the rubber band, if I can get this on here. You know, I did it right in practice. Okay. I smell a blooper. I should have a scribe here. Alright. It only messes up when I try to move it. Okay, see how easy that was? Okay, let's put on the rest of them. This is 10. Okay. Okay, we're dialed in here. We extended our spindle out. We're about 5.5 inches on the stick out here. Of course, our zero is like right here, and nothing sticks in the spindle until you're like 2 out here. Just because this is old, this has been modified and hacked on, and anyhow, it's doing a job. I'm set up in the bit here, and this is This is still running our Arno bit that we picked up last year at the East Tech show. We looked at them at the East Tech show, and then this was sent to us, and we're still testing it on this product here. And we'll be testing this on some Aquamet material too. We're going to save the other virgin side for that. So we've got two surfaces on that end, as long as we don't crash it and break it. And we're going to go ahead and give it a skim on the face, and we're going to be turning that diameter right there. We got to go ahead and we got to get some oil here on our ways. Okay, so we're nice and wet now. All right. And I'm not real thrilled about cutting this hot face on here, and I'm going to lay a rag down here. And the reason why I'm laying a rag here is just so that debris doesn't get down underneath those ways there. And if it snags and flies out, we'll just have to stop it. Alright, but I like to protect my investment there. Alright, let's see what we got here for speed and feed. And I think that looks good. Alright. We're running about 265 on the RPM, and we're cruising along about 8 thousandths on our feed. We're going to go ahead and kiss off our face here first. Now, face cut's about half, I believe, of the travel as far as the feed rate going. That's some pretty good material. The sound, I'm happy with the sound. It doesn't sound so tinny. It doesn't feel like we're moving around. This is bare minimum off these links here because I got the part like right on the money. Within about 1/8 of an inch per part on the material. Now I'm just taking this in until I can just safely say that I've got a clean face. When we do the bore, we'll be cleaning that right on up. Okay, yeah, it's looking good. Alright, we just need to clean up there. Try another 25. Alright, we got a good clean face. Now we're going to go ahead and we're going to take our first cut off the outside here. Now a lot of people ask why I use oils instead of flood coolant. Well, I have very little room to work around. I have a catch bed that would catch the fluid and stuff, but my tracer attachment and this whole unit back in here and how close my gantry runs to the back of the lathe and all the general room in my shop does not allow me to have a guard or a grill or a backboard, a dam to control the coolant flying around. And that's why I don't have coolant in here. Now there's stories about shattering bits and things like that because of using brushed on coolant. I have not found that I have failure in the inserts because of coming in too cold or whatever. This is room temperature. This is very lightly. I spread it even on the part all the way around here. So it's not like coming from hot to ice cold freezing temperatures. Now if you had intermittent coolant spraying on there, you could have a problem, because then you got something that's absorbed with a lot more coolness. Alright, that's my take as far as brushing on the oil versus flood coolant. And I just don't have designed room to create the catcher for flood coolant. Okay, I'm going to try to take 50 here. That's handling pretty good. Let's see, how much do we have? All we have is a little bit more. Let's try to get all that shell cut off in one pass, so then I can just do the rag with one pass, and then I can just go open ways after that. I don't mind chips with oil, but not this crusty stuff. That makes grit, pasty grit. That's like cast iron. Okay? There's 75, 150 up the diameter, but 75 total from where I touch. The fat area. Okay, that's almost cutting all the way around. That's going to be close enough. And, alright, it's caught up with the other one now. Tight in there, so I don't know if it's going to grab the rag and the chips or what. We got a 1/4 inch more to go. Counting down. As soon as we get to the end, I am going to stop it, even if it doesn't grab. Okay, right there's the end. Okay, we were able to run that rag all the way with these chips. They were kind of like holding it in there. This board jaw is smooth on the outside here too, so it's, you know, probably the reason why it didn't grab. They locked in there tight enough, so I can pull this mess out of here now. But see that? That's that debris right there. That's what you want to keep that from getting into your ways. Alright, we're going to go ahead, we're going to take another cut here. Now I got you in because I want to see if I can get the starting of the cut here. We're at 6 inches, 165, and we just need to take, I'm just going to take another 25 off of here, so we got 6 100, just so we have a little bit of material to play with here. Alright, we got to blow it off. We'll come in, we'll just touch. Now we're going to take 25 thousandths, okay? Let's go. Okay, we're about 100 thousandths oversized right now, but it's just nice clean. Now, I'm happy about this face here. I'm going to reach in and I'm going to get in here with my D&MP, and I'm going to whittle that little lip down in there a little bit more. I'm going to just break this edge out here a little bit. We're going to flip this around, kiss the other face, and then we're going to get the other one in here, bring them both to this condition, and then we're going to start setting up this for a line bore on these. I had to laugh the diameter reduction. The hook would go all the way up and it wouldn't tighten up on the part itself. And we had to go ahead and wrap it around twice to get it to seat in there. Alright, now we can't dial this in because this center is still hot roll and it's oddball over here. And we can adjust this over here, but what we're going to try to do is just get this a clean face here. And I'm going to take a look and see how we're running here, whether this is actually worthwhile or we let it go and we're able to re-indicate it after we do the line bore. Okay, she is running pretty true there. We're going to have to put the indicator on over here. About 80 thousandths out. That's looking pretty good. I'm going to go ahead and take a skim on that face right now. And I'm going to go ahead and use my D&MP because I want to get in close there. Got one of our jig supports for line boring, for performing line bores in our lathe. This is I don't know, probably the 4th or 5th job that I've actually used this for, and this is we're pushing it to the largest size so far as the diameter, and I'm pulling out the locking screw, adjusting screws, taking the nuts off and we're gonna lock the bolts in position from the outside of these so that I could get that major diameter to match up for our tubes we got here. The tubes are 6 1/100,000, or just under 6 1/8, and we have like 7.5 here. But by the time you take the head of this and you add that on there, it chokes it down. It's going to be, you know, I mean, we're going to have a little bit of adjustment in here to compensate for just hand machining and hand cutting and arranging these. Of course, this is machined. These are machined in here at the right axis, and this is nice and smooth, and it's located so these things sit square, lock right in here. Now, time to time, we get a conversation of what is an engine lathe and what isn't an engine lathe. And I think there's a lot of different reasons what makes an engine lathe an engine lathe. And I thought that one of the most important things that were always emphasized through the old timers and everything else was that you had a flat deck carriage with T-nut arrangement in the deck so that you can toe clamp and you can support things so that you can hold it on your carriage and then use the spindle as your boring or your facing instrument. And this lathe here just happens, I was really giddy when I saw this lathe and it had everything that it had, plus that arrangement on a table, because not that I thought that I would be using it at that time, I just wanted to know that I had that option. Just a little, it came up recently here, the topic about engine lathes. Anyhow, I dug something out from, this is probably an antique by now. This is a snap-on, but this is back when air ratchets were kind of new. I didn't get it new. I got it used at a flea market in, you know, California or whatever. And anyway, we're going to go ahead and pull these out, take the nuts off, put them back in, and get ready to put this one down in there, and then we'll hunt down the hold down bolts. We'll get the tube in here and we'll see how it's looking. That's laziness at its peak, I guess. It is a long-winded thread, so it was worth digging the tool out and putting an air fitting in the end of it, and a little oil. Thing really doesn't have any nuts. Alright, we just slid our tailstock in after we put our tube in here, and these were put in here, and then we scaled side to side so that we made sure that this side edge and this side edge here was equal to the bar within scale distance. That's going to be close enough because we got 3 feet on each one of them that's going to adjust. Then we tighten them down to the carriage. Alright, we're going to split our difference here. Here's the bit here, so this is where we'll either finish or start, depending on what side of the part we want to start on. And we know there's enough room on that side there to carry the sleeve, and we're about an inch away from our chuck on that side there. So we're kind of, you know, we're setting it up with the consciousness of plenty of room and being safe. Alright, and we got 3 inches there. We got about 3 1/4. We'll just tap it this way just a little bit, about 3/200, 3/200. Now, pretty simple math that we're going to use to get this thing in alignment real quick. And this diameter is 6 1/100, and this is 3 inch. So we got 1 inch, 550. Huh, the combination of that is magnetic. I guess that part is magnetic. Okay. So we're going to raise the lower jack screws until we have 1 550 on the top, and we're going to roll the shaft over so that we have the outside diameter to measure from. Alright. There's going to be... I may actually... Yeah, I can actually set it here, and I'm going to do both of them. This one's a little stout.